This is the last part 4 for this chapter 13 lecture, and this is just something I would invite you to read. Basically, I would like you to just understand the polymers. Poly means many. It's a very large molecule that is just repetitive bonding together of many smaller molecules we call mono. Mono means one, monomers. So those go under polymerization. There's a lot of applications. Some examples here. Ethylene leads to polyethylene. Propylene yields to polypropylene. And styrene yields to polystyrene. Those are things that we use every day, unfortunately, because they are not environmental friendly. So the thing I would like you to know about this mostly is that instead of repeating how many times you have that monomer repeated, we use a parenthesis, and we are going to say that this is going to be repeated many times. So on the far left, ethylene gives polyethylene, and you see I have those parentheses. Propylene gives polypropylene, and styrene gives polystyrene. Just look at some of the application. Packaging bottles, the rope, pails, medical tubing, plastic pipes, foams. That's the one we have for polystyrene to keep your coffee hot. And we have also rubbers for tires, outdoor carpeting, windows, contact lenses, lot of application. Last thing I want to insist on is here understanding the aromatic compound. So this is compounds that have a benzene-like rings. Now a benzene-like rings is going to be a saturated with 6 carbon atoms, and you have double bonds every time you can. You don't need to put a number when you have mono substitute benzene because the ring positions are identical, meaning that you always start with 1. So here it's bromobenzene on the far left. You don't need to put 1 bromobenzene because there's only 1 bromo over there. Other example in the middle, ethyl, 2 carbon atom, ethyl benzene, and on the far right, nitrobenzene. Now we consider the benzene ring itself as a substituent group if it's attached to another parent compound. No, then it's not called benzene, but it will be called phenyl. And those are examples. The phenyl will be 6 carbon atom, 5 hydrogen, and it's attached to something else. So the example we have here, we still, to name that compound, have to find the longest continuous carbon atom chain, 1, 2, 3, 4, 5, 6, 7, only single bond, so it's a heptane, and on carbon number 3, it's attached to that substituent group called the phenyl, so it's a 3-phenylheptane. Well, a few reactions that we have, I'm not going to ask you a lot of questions about this, I just would like you to just read it. Doesn't matter which of the ring hydrogens is replaced because they're all equivalent. And some of the reaction, nitration, halogenation, or sulfonation, honestly, I won't bother you too much with this. And that's the end of this chapter. Yay!